Hi guys. Alright, I'm going to do a video to answer a couple comments. A couple people asked a couple questions or made some observations. I hope this is bright enough. I'd turn another light on, but it seems to glare on the board. So anyway, to get right to it, one of my viewers, Gene, asked or noticed that they're talking about tube diodes, or like your diode tubes, your rectifier tubes. He noticed that the cathode is where the high voltage is, and he wanted to know why, because he knew that like in a triode, the plate's positive and the cathode's negative. Well, we're going to deal with this, and I hope I can answer his question good enough. I'm actually just going to do basically kind of a half-wave rectifier tube in here, and it's a 12-volt tube. I don't remember the exact designation on it, but anyway, you know, you got your primary windings and you got your secondary windings, and put a little dot here and drop down to ground. Now we're going to come out here and put our tube, and we have our plate, we have a cathode, and come out. Now this particular tube is indirectly heated. Come on, focus. Alrighty, let's see here. There we go. It's indirectly heated. I'm going to try putting a light on here and see if that helps. You might see a little glare right down here, but maybe this will kind of help out a little bit. And bring that up a little bit. Now, so anyway, it's indirectly heated cathode, so I won't worry about the filament in here. That just goes to a 12-volt winding. Now, in any power supply circuit, you're going to have some sort of filter. We're just going to drop down here with a simple pi filter, the resistor, and drop down again with another cap. I'm going to tie these guys together. Put a little dot there and a little dot there, and then this goes on out and would feed to our radio, which will just kind of represent as a resistor, because as far as the power supply is concerned, the rest of the radio is just a load, and I can represent that load with a resistor, and we can just call that, like if you wanted to give it a name, R sub L. If you ever see this, it just means load resistor or resistor load. So, now, we're going to look at this two different ways. There are two different thoughts out there on the way current flows. One is conventional, which is positive to negative. The other one is electron flow, which is negative to positive. Now, granted, inside the tube itself, a vacuum tube, it is basically, you can see it as electron flow. We heat up the cathode, we supply positive voltage to the plate, we have electrons flowing. But as far as the rest of the circuit goes, we're going to look at it two different ways. So we'll start off with electron flow. And we're going to look at when the tube is conducting, because that's all that matters. When it's on the other half of the wave, when the tube's not conducting, nothing's moving, no flow of current, so we don't worry about that so much. So in order to get this tube conduct, we do have to have a positive here. And that would make this other side of the winding negative. Now according to electron flow and following Kirchhoff's laws, electron flow says negative positive, so we're going to go around this way. We will not worry about the flow through the filter caps, mainly because once they are fully charged, once the circuit starts running, these will get basically fully charged, and basically all they're going to do is try to keep the ripple filled in so that we have a smooth DC output. So we won't really worry about them. Now we got a resistor here. Now, so our current's going to flow this way. Now according to Kirchhoff's laws, anytime I run into any type of load in the circuit, I have to put a polarity to that load, because they'll have a voltage drop across it. All loads will have voltage drops. So by that definition, the current flows down this way and up. We're going from negative. This will be a negative circuit here, excuse me. We'll be showing negative here, but on this side will be positive. Now it flows through the load, comes back, as it does. We have positive here, but on this side it'll be negative here as it flows through that resistor. We always got to keep flipping through. We got to keep our polarities correct. So from negative to this point here, be a negative on the cathode. As it goes through, it'll be positive over here, because the tube does drop, so it acts like a resistor. So I'll have a negative here, and my drop will give me positive. That brings me back to positive here at the end. Now, so again, negative through gives me a negative on this side of the resistor. We have a drop. It gives me a positive here. There's no drop in the wire, so I have positive here. It gives me a negative here. No drop in the wire. Negative and positive, because there is a drop across this diode, a rectifier tube. Now, a reason why there's no drop in the wire is because we're considering it a perfect wire. Otherwise, we would have to start doing something like this: negative, positive, negative, positive, negative, positive, negative, positive, and you would eventually get it so close together that it would look like just a solid line going through there. So we'll consider the wire perfect. Now, that's following the current electron flow, negative to positive. Now we're going to get rid of these lines again. We're going to look at it the other direction and see what happens. Now again, we're at a point when the wave going through this, as this transformer is operating, that we're on the positive cycle here, because it's the only time this tube is going to conduct. Now we're going positive to negative. Well, we go positive to negative, we get to our first drop. It's positive here, it'll be negative here. Get to our next drop, which is the resistor. Now this could be a choke coil, but it still has DC resistance. So we'll have negative here, positive here. Consequently, going out to the load, again, this is positive, just like it was the last time. So there'll be a positive there, negative here, and then that flows around, going this direction, back to our negative. So right at the tube, in a technical sense, this, as far as the cathode is concerned, it's negative. No matter which direction I flow the current, it's negative, and the plate's positive. But when we come out here, we get past our pi filter, we end up with a positive here, and that's where we get our B plus from. Now, in the most technical sense, if I wanted to, I would actually be showing this inside the tube, and basically it would be a positive right even at the tube pin, because there's a little bit of drop inside here that would create a positive voltage there. But in a general sense, that's basically how this works. It just boils down to Kirchhoff's laws. Now you can look up those laws by Google them. I've done a couple, 3 videos on them, so you can look in my videos and do a search for Kirchhoff's laws, and you can see what I'm talking about. But basically everything has got a drop. Every load has a drop, every resistance, and the tube itself is a drop. Even if I use a solid state diode here, the forward current, in other words the current where it's flowing, where one side's, you know, it's actually conducting, there is a little bit of drop of voltage here, about round 0.7 volts for a silicon diode, like a 1N4007. So I would still have this thing going on just this way. So I hope that kind of answers your question without really getting in too deep into this. Now the other question, and if you have any more questions, just go ahead and post in our comment, and I'll see if I can help out on that. Okay. I guess there's 2 other questions I want to answer. But anyway, the next question deals with, it's from viewer 4 Hammonds. And he's trying to understand tube amplifiers, voltage tube amplifier circuits, where the circuit begins, how to follow it, and where does it end. Well, we'll just draw out a simple circuit and see if we can answer this question. So we got you know, we're just do a triode tube. My circles are never perfect. So, actually that's probably a little bit big. A little bit smaller. There we go. So we have a plate, comes out. We have a grid. We have a cathode. Alright. Now, in the simplest terms, the grid is your input. The tube itself is the amplifier. So the grid is the input and the plate is the output. Actually, technically, it's the grid to cathode. This part here is input and this part here is output. But let's draw in some stuff here. Now, this would go on to probably a capacitor to feed the next circuit. We'll have a resistor here. They'll come down, and this would go down and go to B plus. We'll just go ahead and ground the cathode. Now in some circuits, well, in this case we'll actually go ahead and not ground it. We'll go ahead and put a resistor in the cathode. Okay, and we'll put that to ground. On the grid we need a pull down resistor or load resistor, or also known as grid leak resistor, which is, you know, works. And then this will come out here, and there'll be a cap here, and then you'd have your input, and your input here would then go to ground down here. So you'd be feeding a signal in here, and you'd be taking out the signal over here. And to give you some idea, this would probably go to just to something similar to this. We'd have another resistor here, like this grid resistor will just go G, R, or better yet, let's just put R sub G for grid resistor. That'd be a better way of doing that. And this is cathode, C, R sub C, cathode. And then this is the plate resistor, R sub P. Now, the way the circuit works, first of all, we start off with a set bias, and I'm going to do a video on exactly how you figure that bias out, but I won't do it in this video, but it'll be coming up after this video. So the next upload after this one, be looking forward to that. But the tube starts off with a set bias voltage, which is determined mostly by this resistor in the cathode. Well, actually this resistor and the load, or plate resistance resistor. Now, if we're doing a Class A amplifier, that means that this grid is biased to a certain negative voltage that when I send a signal in here, which will be an AC signal, it's going to look like this. When I send that signal in, the entire signal is amplified out here on the plate circuit. Now if it was Class B, only half that signal gets amplified. The Class C, only just a small portion is amplified of 1/2. The Class A, the entire thing is amplified. So we got a signal that comes in. What it does inside here, it's going to vary the voltage on this grid. Now that voltage starts off at a certain fixed voltage. We call the bias voltage. As this goes positive, that makes this grid become more positive, or less negative, better term, which allows more current to flow through the tube, which then in turn creates a higher voltage drop across the resistor. Ohm's law is the voltage drop on a resistor is current times resistance. So the more current that flows through the resistor, the greater the voltage drop here. Which reduces this voltage here on the plate. So the signal would look like this, just 180 degrees out of phase, but much larger. This hits a certain peak, maximum current going through. Then as the signal goes down, approaching zero, this is becoming more negative. As the signal goes more negative, goes the other side of zero, this increases this voltage, negative voltage on here, which is reducing the current through the tube, which reduces the voltage drop on this resistor, which shows up with more voltage on the output. Now the way that works is simple. I've got, when that tube is operating, I've got a flow of electrons that's going from my cathode to the plate. I got this piece of wire in here, which is just a coil of wire that's around that cathode. Okay, looks like a spring. the more negative I make that wire, like charges repel. So the more negative I make that wire, the less electrons can make it through to the plate. Less electrons to the plate, the less current flow through the circuit. Less current flow, less voltage drop here, more voltage showing on the plate right here. If I decrease the negative on here, in other words, the signal is going positive, and I decrease this signal, then more electrons can make it through, and that way more current flows, more current through this resistor, the greater voltage drop, and the less voltage on the plate, which is shown here. So the input of your tube circuit, and it depends on who you talk to on exactly where the point is, but some people will tell you that the input to the tube circuit is right here. So in other words, the capacitor is part of this grid circuit. Other people will say no, that's part of the previous stage, like right here. It doesn't matter. The input anyway is this point, is the grid, known as the control grid. Now this tube could have more grid elements in it. I could have a tetrode, if I can get the marker to work. So I could have another grid in here, and we call that the tetrode, and this would go through some sort of resistance and go to a B+. Hold on. Okay, now in a tetrode tube you'll have another grid here that we call the screen grid, and it's connected to B+, usually through some sort of resistance to reduce it. Generally it runs at a little bit lower voltage than the plate. But don't get it confused with the control grid. No signal is put through it. Now then on a pentode tube you would have another grid which would come around here. In some older tubes it may exit on a tube pin. Most a little bit newer tubes, it is actually internally connected to the cathode, and that's called the suppressor grid. Now these grids were put in here to help out with internal capacitance, help out with the current flow flowing through. The screen grid allows me to effectively increase my plate voltage on a tube, because with a triode tube, if I get too much plate voltage on it, what ends up happening is the flow of the electrons through the tube is at such a great speed or velocity that not all of them actually get attached to the plate and continue the circuit in current flow, but actually bounce off and outside the tube. This grid here being slightly less positive, but positive nonetheless, when those bounce back off, they see this here, but it's actually a little less positive than the plate, so effectively the difference in voltage, it looks negative to those electrons somewhat. This is more of an appetizing area to go to, but it actually effectively slows them down, and so that they can go back to that plate. Suppressor grid continues that process to even slow them down even slower and keep more of them on the plate. But this grid right here, G1 is what they'll be called, is your input grid. Now that's on just, triode, tetrode, and a pentode tube. Now there are some other tubes out there, basically used in front-end radios for on super heterodynes, called mixer tubes, converter tubes, first detector tubes, and those are somewhat more confusing for people. We draw one out here. Okay. Let's try green this time. We have a plate, and that's going to go off to B+, and a cathode. We're going to have one grid, grid 1, two grid, number 2, number 3, number 4, and number 5. Now, depending on which one it is, either these two will be connected or these two will be connecting, depending on the tube. But this will not be your control grid in these type tubes. This will actually be used for either one or two things. These tubes are generally used in the front end of a radio. They're called pentagrid. In other words, 5 grids. And this exits out somewhere. And what they do is they'll either use them strictly as a converter or mixer tube and have a separate local oscillator tube, which in that case will probably generally feed the signal in from that local oscillator on this grid. Or they'll use the tube both as a mixer and a local oscillator. In that case, this grid, and this becomes the local oscillator. This will always be supplied with a positive voltage, and what they'll do is this will be the plate for a little triode type section of this tube. This will be the plate, or act as a plate, an anode, because it's got B+ on it, and this, and along with the cathode, will be connected in, and maybe even with this plate, connected into the oscillator coils, and that will make up my oscillator for my local oscillator. Then this grid here, either G3 or G4, depending on which tube it is and depending on which one of these are interconnected, there'll always be 2 grids that are interconnected, will be the signal grid that comes in. It'll be the actual control grid that is fed into the tube. So it will not be grid number 1. You have to look in your tube manual if you're just looking at a tube, or you'll have to look at the radio circuitry to see. Now, to give you some idea, I'm going to be doing a radio before long. Now, this doesn't have a pentagrid in it, it's just got a pentode, because it's got a local oscillator tube of its own, and they decided to use a 6D6 pentode. I'll later, when I start working with this, I'll actually bring out some other schematics like an All-American 5 radio to show a pentagrid. Now, these older radios where they got, and there are pentagrid tubes that were older tubes like a 6A8, that would have a cap on it, a grid cap, and that makes it real simple. That's your control grid. But if this had a pentagrid in here instead of pentode, it will always be the grid that goes to the antenna circuit. That's your incoming signal, and that's your control grid. Now, in this, trying to understand where input and outputs are on the various tubes, let's look at this one right here, because it's a little simpler to see. But basically, everything before this cap is just the signal I'm inputting in. This becomes right in here and all the way around through this coil is my circuit, my tube circuit. So if I would effectively do this, this is kind of what I drew before. There. Now I've got some extra stuff down here because the way the power supply is set up and everything, we're supplying this supplying a little extra negative voltage to the grid. Plus we do have a cathode resistor. It's redrawn a little differently than what you normally see, what I showed. But here's your input right here to the tube. And the output here goes to the transformer, primary, which then feeds the speaker. If we was looking at, say, some other tube, we may not have all these resistors, but let's look at this tube, IF tube. Your input is a secondary coil feeding in through the grid cap to the control grid. Your output is through this primary winding on the IF transformer. So hopefully that kind of helps you answering some of your questions. If you're still a little confused, just drop a comment on here and I'll see if I can do a better job at this explaining it. So anyway, oh, one other last question. I said there was another one. There's another viewer, Freddie Machado, M-A-C-H-A-D-O. Don't know how to pronounce that for sure. And you asked, you like my math videos and want to know if I had any books to recommend. I don't really have any actual recommendations other than algebra, any and all levels of algebra, including trigonometry. So my best advice on this is two things. One, you can actually do a Google search for like say electronics math PDFs or download or book downloads or something like that. You'll find sites that you can get free downloads of several different math books. And also some sites, you know, of course, you can buy the books as e-books or even printed material. The other recommendation, and this goes for anybody, is before you ever purchase any type of math book, most local libraries have math books in the library. You know, basic math, algebra, algebra 2, trigonometry, and so forth and so on. And they also got, you know, electronics books and electronic math books. Most libraries do. So go in there and check some books out. Check them out. See if you really like them. If you like the book, you can either try doing a search for it and see if there is some place that you can download it for free, or at least be able to, if you really want to have the book, you know, Amazon.com or someplace to purchase one. But anyway, by using the library, you get, you know, a book title, an author, and so on for the information. So, plus you get a chance to actually look at it and decide if this is what you're looking for or not. So either Google, and you're looking for like downloadable PDF for, you know, math or electronic math books, and or you can go to your local library, or both. So that's my only recommendation I can give you. I don't really have right off the top of my head any particular author or book in per se. So I hope that helps you. So anyway, that's about all I've got. Hopefully this video turns out alright and everything stayed. I tried watching the screen, but hopefully everything stayed in focus. And I hope I explained this stuff good enough. So anyway, guys, if you like the video, thumbs up. If you're just watching my videos, you haven't subscribed, if you're some of the people I answer the questions on here, I don't know for sure if you've subscribed or not. If you haven't, I recommend subscribe, because you'll know then when new videos pop up, Either you get an email, or at least you'll see them in your subscription list of any of my new videos that pop up, including this one. So this one I'll be uploading today. This is Saturday the 27th, and then in the next couple 3 days or so I'll do a video on and we'll just take a triode tube, but on how you actually find that operating point, that bias point. It's actually really pretty easy and simple. So thanks again for watching. Thanks for new subscribers I've got, and I'll see you guys on the next video.